Good evening, all of you. Today I'll be taking about flow control statements. This is a revision 3 about the if loop, for loop, repeat, while, all these things. Okay. So I will start with the if loop. So this is the first command. So we are seeding the random number generator because I'm going to make a random number generator in the next line. So to get the same number, we have to seed the random number generator with the number so that each time you will get the same random number. So I'm seeding that with one number 1890. So in X I'm making a random number, one random number I'm making with the function rnorm. So I have made. So this loop tells if X is less than 0 it will print negative, or if X is greater than 0 it will tell positive, or else it will tell it as 0. Okay, so this is the if loop till here. Okay, one condition is there and you can print equal to that, and then another else if here and one else. Okay, so this is the command for that. You can, this is the if loop. So it tells X is positive because the value of X is 0.73, so it is greater than 0, so it is telling X is positive. Okay, now you can use else if statement or use nested statement. Okay, so here X is given 122, and now you can see here if X is less than 10, print less than 10, else if X is less than 100, it will print between 10 and 100. See here two else ifs are there. Okay, more than to show that, and last one else command. So here it will print it is between 10 and 100. We can see. Okay, between 10 and 100. So here I showed two else if statements can be combined, and there is no need of this encapsulation if you are writing in one line. This example shows that X I am giving true and Y is given pi, and then if X then 1, otherwise 2. So here X is true, so you can see X is Y is given the value 1, because so here you can just change this to false, and then you can see now y will get 2. Okay, so if it is in one line straight line, then no need of curly brackets, no need of encapsulation. Okay, and then here I'm giving X values from 1 to 6. Okay, 1 to 6 it has come, and this gives a remainder. Okay, mode or something you can say. So divide by 2 and the remainder. If the remainder is 0, it is even. If the remainder is not 0, then it is odd. Okay, this command. So as you can see, first number 1 is odd, 2 is even, like that. Odd, even, odd, even, odd, even. So 1 to 6. Each number is divided by 2 and we are checking the remainder. And now another flow control is switch. So here you have given X as character B, and based on the value of X you are assigning values for X underscore info. So if it is A, 1 will come, B, 2 will come, like that. Okay, so let us see. So we are assigning B for X and we are using switch command. Okay, so here switch command, so X underscore info should get 2. Okay, X because it is B based on the value of X. Now this is just another, this is an example of switch, but it can be implemented using if also. If X equal to A, 1, else if x equal to b 2. Same thing, we have done using one switch command, this command. Okay, you can see here. Okay, just that. And another flow control is for loop. So the syntax is for value in vector, and statements. You can see here. So x is having a to e, first 5 letters. Okay, a to a b c d e. So for j in x, print j. Okay, so it will a b c d e will be printed in one line. Okay, there is no need of increasing the value of j. That is done automatically in R. As no need of j plus plus or not, anything like that. It is automatically done here. That is the difference in R. So again, I am making a vector x. So you got the values 0, 1, minus 1, 102, 102, and one for loop. I am getting printed those values. And another flow control is repeat. I am making a vector with 1 and 2, and C I am assigning a value of 2, and I am giving a repeat loop. But one break condition should be there. Repeat, here you are printing x plus c. So 1 plus 2, 2 plus 2, like that. Okay. So when c is greater than 4, it will get break. It will come out of the loop. Okay. So here c is 1, 2. So 1 plus 2, 3. 2 plus 2, 4. That's why 3, 4 came, like that till c is greater than 4. And you have to, this break statement is sorry, break statement is compulsory for the repeat. And here we are using a while loop. Same, while c is less than 4, same thing, 3, 3, 4, 4, 5. And now just to tell you about the speed of the loops. Okay, so here I am giving one 10 raised to 7 value to n. So n is having 10 raised to 7. So v1 I am 1 to n. So you can see this has values from 1 to 10 raised to 7. Okay, and then I'm going to multiply each value in v1, 1 into 2, 2 into 2, like that. So I'm going to calculate how much time that command will take. So t0 will have the current time, and then we will multiply each value in v1 into 2, and then when that is over, we will find the system time minus the t0, the current system time minus the previously stored time, and print that value. So thing is that you have to execute these 4 lines together, then only you get the proper difference. Okay, so difference is, so it has taken 0.139 seconds. Okay, so here what we did, we have multiplied each value in v1 into 2. Okay, for that we took 0.13 seconds. So now let us see how it will work in a loop. So I am removing the v2. V2 is removed. V2 we have a null vector. V2 has null vector. Now again I am putting a loop, for loop, each element in v1, and we are assigning that element into 2. We are putting a for loop, and let us see how much time it is taken. So these 4 commands we are executing together. So initial time this is 6 dot time will give the system time, and then we will execute the for loop for k in v1. So each element we are taking, and then we are putting it into another vector, v2 of k equal to v1 k into 2. Okay, and then we are finding how much time it is taken. Okay, take some time. So difference is, it took 7.54 seconds. So we can find how much is the difference. So just executing this one, t2 as numeric, you are converting that into numeric and dividing. So how much fast, so we will see what is in the t underscore rel. So 54 times, our loop was 54 times slower, or when we multiply directly it was 54 times faster. So the conclusion is use operators, that means use this one whenever possible, that is much faster than using the for loop. Okay, so use operators at the highest level for the vectors, matrices, etc. As we saw it now, for the 10⁻⁷ numbers, it was 50 times faster when you use the multiplication directly. Okay, so that's all. So just a recap, I took if, else if, for loop, repeat loop, while loop, and also I demonstrated the time difference using the system time. Thank you. If you got any doubt, you can just comment. I'll reply to that. Thank you. Please see and subscribe my channel. Thank you.